Okay, so welcome back. We are on Unit 6, Lesson 1, which is log and exponential functions. Now I'm going to go through the entire bits of notes. You have already seen this in class, but you're going to see them again. So first thing we're going to do is we're going to introduce logs. So how do you find logs? Now if you remember, the base here is 2. And the reason why it's 2 is because the number that has the exponent of 1 is always the base. So your base is 2, okay? So just remember that. Now, what you need to find out is all of these numbers are what they equal. And now we're trying to find what are the exponents for all of the numbers. Now remember, the base never changes. The base is 2. And the red numbers are your exponents and the black numbers are what they equal, okay? So this number here would represent 2 to the 1.58 is 3. This number here would be 2 to the second is 4. Now, how do we figure out 6? Now what you do is you take two numbers that multiply to equal 6, and those are 3 times 2. And now you look at 3 times 2, so we look at 3. The exponent is 1.58. And we look at 2 and we see the exponent is 1. So 1.58 plus 1 is 2.58. So 6 is 2.58, and it reads 2 to the 2.58 is 6. How would we figure out 9? Well, you figure out the two numbers that multiply to equal 9, which are 3 times 3. So 3 times 3 is 1.58 plus 1.58, which is equal to 3.16. So 9 is equal to 3.16. And how it would read is 2 is your base. The base never changes. So 2 to the 3.16 is equal to 9. Now let's go down here to this chart. Now again, whatever number equals to 1, that's going to be your base. So your base for this chart is 3. Now, how would we find out what 10 equals? You figure out what two numbers multiply to equal 10. So 5 times 2. And then you look at their corresponding exponents. So 5's exponent is 1.46. 2's exponent is 0.63. You add them together, and you get 2.09. So 10 is equal to 2.09. And the way it would look is you would do 3 to the 2.09 is equal to 10. Now we want to figure out, there's a difference between log form and exponential form. Now log form here is log of b y equals x. And the way that looks in exponential form is b to the x equals y. Okay? Your base is b, your power is x, and what it equals to is y. So when we're in log form, our base is b, what it equals to is y, and our exponent is actually x. So it's switched when you're in log form. So now what we want to do is we want to rewrite, if it's in log form, we want to rewrite it in exponential form. If it's in exponential form, like d and e down here, we want to write it in log form. So up here we've got log 2, 32 is 5. Now remember, the base is here, so it's going to be 2. Your exponent is 5, and it equals 32. So 2 to the 5th is equal to 32. So over here, our base is 5, so it's 5 to the 0 equals 1. 5 to the 0 equals 1. Now let's look at C. C says log 10, 0.1 equals a negative 1. Our base is 10, so 10, right here, 10. Oops. 10 to the negative 1 right here, is your exponent. So 10 to the negative 1 is equal to 0.1. 10 to the negative 1 is equal to 0.1. Now d and e are written in exponential form, so we need to change them to log form. So d, your base is 10, your exponent is 1, and it's equal to 10. Now remember, in log form, your base is 10. So log to the 10, log 10 to the 10th equals 1. Now if we look at e, our base is a half, so log to the 1/2, log 1/2 to the second is equal to a negative 1. Okay? Now how do we evaluate the expression? So up here we're just rewriting. We're rewriting log and exponential forms into each other. Now we need to actually evaluate them. Evaluate meaning to solve. So log 3 to the 81 is equal to what? So now let's change it into exponential form. So our base is 3. We don't know what our exponent is because we don't know what our equal sign is. So 3 to the x is equal to 81. Now we know 3 to the x, 3 to the 4 is 81. So x has to equal 4. But what if we don't know? So here we've got 5 to the x is equal to 0.04. We do know that 0.04 is 4 over 100, and we can reduce that to 1 over 25. Now, anytime you have a fraction, your exponent is usually going to be a negative. Not always, but that's usually the rule. So 5 to the negative 2 is equal to 1 over 25, because anytime you have a negative in your exponent, you're going to make it a fraction. So this would technically read 1 over 5 to the negative 2, which would equal 1 over 25. So your x is going to be a negative 2. Now for this one, you're going to use the properties up here to solve for each of your logarithms. So down here, for example, 1, it gives you log 5, 3 divided by 7. Now if we go back and look up at our rules, anytime that we have division, we actually subtract. So that's what we're doing down here. Log 5, 3 over 7. Now it gives you what log 5 of 3 is. It's 0.683. It gives you what log 5 to the 7th is. It's 1.209. Now the rule says anytime you have division, you subtract. So let's do that. 1.209 minus 0.683, and that equals 0.526. But the 3 was first, so we're actually going to subtract the smaller one from the bigger one. Anytime you subtract small from big, it's actually a negative. So now let's go down to log 5 of 21. Now, we only know what log 5, 3 and log 5, 7 is. So 21 has 3 and 7 in it. So we're going to break 21 apart into 3 times 7. Now let's go back up to our rules. Anytime we multiply, we're actually going to add. So we've got 3 times 7. 3 is equal to 0.683 and 7 is equal to 1.29. We add those together and we get 1.892. Let's go up here. When it tells you to expand, we're actually just going to expand it. We're not going to solve. So anytime that you have an exponent, anytime you have the exponent has an exponent, the last exponent goes in front. So here we've got log 2, and we've got an exponent. So our exponent goes in front. So 3 log 2, 7x. Anytime you divide, you actually subtract. So subtract log 2y. Down here, we've got 2 exponents. So we've got 6 log 5 to the 2x minus 2 log 5, 3y. And then down here, again, you're dividing, and we also have 2 exponents. So we have 3 log 4y minus 5 log x. Now what we're going to do is instead of expanding it, we're going to do the opposite. So here, we're going to condense it. We're going to make it smaller. So now we're starting with our adding and our subtracting, and we want to either multiply or divide. So here, when we add 2 exponents, remember we multiply. So log 2, now they all 3 have the same base. So instead of writing log 2 multiple times, let's just write it one time. So log 2. Now here we've got 6 and then 2 to the second. So we're actually going to write 6 times 2 to the second, and the reason why is because when you add, you multiply. Now remember, when you subtract, you divide. So we're going to divide that by 3. So we've got log 2, 6 times 4, because 2 squared is 4. We're going to divide that by 3. And that gives you log 2, 6 times 4 is 24, divided by 3 is log 2 to the 8th. Now here, again, we actually only have 2 of the same base. So here we've got log and log, but the third one is log 2. So that's going to be off to the side. So let's do the first 2. Now remember, if there's ever a number in front of log, then that means it's an exponent. So log 7 squared. Now when we subtract, we divide. So divide by x to the 5th, subtract log 2, 3 squared. Okay, so that's going to equal 7 squared is 49. So log 49 divided by x to the 5th minus 3 squared is 9. So log 2 to the 9th. Now we're going to go ahead and condense here. So first we want to see, are all of our bases the same? They are. So we just need to write log 8 out here in front. Now anytime we subtract, we divide. So remember, if there's a number in front of log, there's an exponent. So we've got x squared divided by, we don't have a number here in front, so we don't have an exponent. So that's divided by 5. And then here we have y cubed. And again, it's cubed because the 3 is in front of log. Now we're just going to, when we come down to common and natural logarithms, what we're doing is when we have log 3 to the 7th, we actually just want to make the bases the same. So all you're going to do here is if you ever see log 3 to the 7th, you're actually just going to divide. So it's going to say log 7 divided by log 3. Your exponent always goes on top. So here, log 6 to the 15th, it's just log 15 divided by log to the 6th. Again, you're going to have x equals, so here we've got 3x to the 14, so we're going to have log 14 divided by log to the 3, because remember that 14 is actually your exponent, so log 14 divided by log 3. The same over here. Okay, this reads x equals 2 to the 21 because your base is 2 and your exponent is 21, and your exponent always goes on top, so log 21 divided by log 2. Okay, that's the end of Unit 6, Lesson 1.